I welcome you specially to the 17th International Conference on Wireless and Mobile Network 2025. Yes, my name is Ifeanyi Nwokoro. I'm a professor of computer science, now with Southwestern University, Nigeria. So I am going to be presenting a topic with title Intelligent Cognitive Engine for 5G Network Quality of Service Management. And if you can see my screen, please kindly confirm.
Yeah, we can see your screen, Professor.
Oh, very good, very good, very good. Okay, so I have to break this work to a kind of with a reference to a layman understanding, so that it will not be cumbersome. It's a review, of course. So I had to break it down so that we'll have good understanding when it has to do with quality of service with regards to 5G networks. Yes, this article proposes an AI-based cognitive engine to manage quality of service in 5G network, and it also addresses resource sharing and distribution in 5G. And there are a lot of challenges in managing quality of service in 5G. And the background to this work will be centered upon the transition to 5G brings unprecedented demands and network infrastructure. When we say unprecedented, we are looking at resource sharing, the urgent and important obligations, be it in ad hoc on demand distance vector or destination sequence distance vector, or even NAT-based, based on resource sharing, based on impact and usefulness of such resources. We'll have an automated sharing system that has a kind of more enhanced qualities with reference to the 4G quality of service mechanism. Yes, and the statement of the problem, we have exponential growth in data traffic, which has been a concern to all of us. We have diverse service requirements, high throughput, ultra low latency, and the massive device connectivity. I am of this opinion that most of our users in some of these wireless networks, we have over 50 billion users worldwide, which is ample, which is sufficient, so that we have to look for a profound way that we could use to share our resources. Yes, having said that, we need an intelligent adaptive system for quality of service management. And we look at need for innovation. Why do we go this far in this innovation? Why do we have to go this far? So the static network management method can adapt to dynamic 5G environments. There is a need for intelligent autonomous systems capable of real-time quality of service management. And we look at the objectives to this responsibility. To propose a memory-based AI-powered cognitive engine for efficient and adaptive quality of service control in 5G networks. So having said that, let's dive into some very, very germane questions. Why do we ask for quality of service in 5G? Is it important? Is it necessary? Is it obvious? So, 5G network are expected to handle more devices and deliver results with efficiency, reliability, and otherwise. It ensures important services like video calls, emerging responses, and Internet of Things applications. Because just as we speak currently, we are on a conference call, and allocation should be appropriate, at least in this scenario. Resources should be allocated for video calls, emergency responses, even Internet of Things, be it home-based Internet of Things or industrial-based Internet of Things. So 5G service categories that are incorporated into this review. We have the enhanced mobile broadband for high-speed internet. We have the massive machine type communication for IoT and sensor networks, like the ad hoc on-demand vector. Mission critical applications like surgery and autonomous vehicles were used for ultra reliable low tenancy. Okay, we look at the core quality of service features. We looked at the ultra low latency, which has about 1 millisecond, high throughput and reliability, and or what have you in this research. So let us look at the players in this an engine that we want to discuss. So we have a trust to mobile network. We have about 3 players there with the subscribers requirements through their request, and the subscribers that have a privilege and authenticity. And we have the general requirements on this network, and we have the regulatory paradigm on the ethics and the privileges on network usage and otherwise. So trust to 5G network on quality. We have the quality of experience domain. We have the quality of service, that is QoE, QoS, and we have network performance domain. Okay, we have a user, perhaps, and the mobile device at which the user engages inquiry, and there's 5G network and there's an application server. So these are known as the trust to 5G network security. So let us look at the challenges that we have in 5G network in line with our research, which was conducted. So we have challenges. The traditional quality of service systems can't keep up to the volume, speed, and complexity of the 5G. That is the conventional system that has been in place. And the old models are insufficient, are not perfect, are not vibrant in data handling and self-optimization and correction. We still have latency system limitations. The traditional 4G light infrastructure lacks adaptability and efficiency in 5G speed and diversity. Yes, and service diversity and complexity. 5G supports a broad mix of applications, just like we've discussed, the enhanced mobile broadband, the massive machine types, and the ultra reliable systems. So why do we need autonomy? Because manual configurations and static policies are very, very insufficient. And the network must be capable to self-configure, optimize, and adapt with AI-driven solutions. Yes, we'll look at an acronym FCAPS, FCAPS, and SLA, Service Level Agreement. FCAP in this methodology would be a fault management, configuration management, accounting management, performance management, and security management. What do we mean by that? Fault management detects logs and resolve network faults in cognitive engine. And configuration management would monitor and control network settings. Accounting management would track usage for billing, of course, and analytics. Performance management evaluates system efficiency throughout the life cycle of the system, and there will be security, making sure that the system is thorough, it has profound trust level agreement. We have a service level agreement which defines expected performance levels across various services and ensures accountability and security, of course. The role of machine learning, that is where we want to bring insightful idea into. Why machine learning? Because this FCAP will be automated and it's going to be proactive and it's going to be rapid in recovery and discovery and pronouncement of such attributes with regards to the FCAP analogy. And it's going to predict quality of service breaches and adjust parameters to preserve service level agreements, commitments. It will enable self-configurations, reconfigurations, healings, adaptive capabilities in 5G systems. So let's quickly look at the machine learning architecture. So we are going to propose an AI power system using deep reinforcement learning, DRL, and memory-based neural network. Why? Because this engine can learn from past network behavior, that is comparing note in the predictive F1 and other scores that would be integrated into the system. And it's going to make autonomous decisions in maintaining high quality of service. It has the data service layer. It has the machine learning engine. It has the planning decision layer, and the benefits enables adaptive real-time quality of service management, reduces reliance on static rules and manual interventions. So the machine learning proposed system for 5G FCAPs would have about 4 attributes: the 5G environment, the network data service, the network services, the network planning service. So when we have the 5G environment, we have the data source, and the data source would also migrate through machine learning services, specific data to data gathering and preparation of service, which will lead us to network throughput. And dimensionality, reduction service, and the data would have kind of a warehouse, the data linkage, and which a lot of activities will be carried out, and there will be trained system or data sets that will help us predictive recovery and analysis. And at the end of the day, the machine learning service will lead us to the cognitive smart engine that would either accept or reject network decisions. And in a scenario that is being accepted, the planning system is affected. So the cognitive smart engine functions, how does it work? The system uses machine learning layers to pre-process, predict traffic patterns, plan resolution, allocation, even do allocations proper. And the data is filtered, and there will be priority after that. And at the end of the day, there will be deep reinforcement learning, which will have some functionality as in it monitors traffic events at access points and predict congestion and traffic deadlock, and adopt routing and scaling policies accordingly. It would prioritize traffic, the first in, first out, the last in, first out, or any other protocol that is part of our trained set. It will prioritize it as agreed. So the impact is improve subscriber comfort experience, and it's going to also improve the quality of service experience. So the result that we're going to have, of course, have enhanced performance metrics. The 5G quality of service would give us an enhancement from the 4G, which has been so rampant in this wireless system, and intelligent package management, effective prioritization, and the routing of high-value data streams. it will going to prompt discarding of violating or noisy packet. The noisy packet will be streamed, and the ones that are not vital would be expunged from the system. Yes, there will be a higher subscriber comfort experience, and the engine will have some advantages. It demonstrates self-learning, self-healing, and self-correcting behavior. It will outperform the conventional 4G network quality of service. Conclusively, the proposed intelligent engine can autonomously manage and optimize 5G network, improving quality of service without human intervention, because it will have trained data that will help us to achieve that. It will represent a key step towards more adaptive, efficient, and trustworthy network management in future smart environments. The summary of contribution: we introduce an AI-driven cognitive smart engine for proactive and autonomous 5G quality of service management. We leverage memory-based neural network and reinforcement learning to enhance network intelligence. And there are some benefits on that. The real-time traffic monitoring and decision-making, improve the quality of service, quality of experience, and service creation environment across diverse specifics and services. We reduce congestion and packet loss and mysteries in a dynamic environment. Yeah, strategic impacts, support self-optimizing, healing, and otherwise. Prepares telecom infrastructure for future high-density mission critical 5G applications. And the final note will be this research bridges the gap between the theoretical AI and practical 5G network operations. Yes, and we have some of our references from IEEE and other platforms that have done critical analysis with regards to the conventional 4G and the convolutional systems with regards to machine learning and deep learning applications. Yes, thank you so much for being here and for listening. I will entertain questions at this point.